Okay, let's start now. So, in this lecture, we will solve questions from Boolean algebra in digital logic. Some standard questions we will solve, some standard book questions, and also some university questions. Okay, so let's start now. Am I audible? Please let me know. Is the audio clear? Audio, video, volume, is everything fine? Let me know. So first we will start with some questions from this book. So this is a very nice book on digital logic design. This is by Charles Roth. So you can see in this book a lot of questions are there. Okay, so let's solve. First we will solve some easy questions. Let's start with those. Okay, so let's start with some easy questions. So tell me the answer for these questions. Okay, and also keep a copy pen with yourself because we are going to solve a lot of questions. Okay, a lot of number of questions we will solve in this session. So keep a copy pen with yourself and tell me the answer for this question. So this question is saying that determine the output of each of the following gates. So some gates are given to you. For example, this is your OR gate. Now, in the OR gate, if both the inputs are 1, then what is the output? The output is also 1 because we know that this is the behavior of OR gate. 1 or 1, that is 1. So this is your OR gate, and when the both inputs are 1, then the output is 1. Actually, in the OR gate, if at least one input is 1, in the OR gate we know that 1 or anything, okay, 1 or anything, that is 1. Next, in this, what is the output of this gate? This is your AND gate. In the AND gate, you can notice if at least one input is 0, then the output will be 0. We know that 0 and anything, that is 0. Okay, so if at least one input is 0, okay, then we can say output will be 0. This is again your OR gate. In this OR gate, you can notice if at least one input is 1, then the output will be 1. And this is your AND gate. In the AND gate, output will be 1 if and only if both the inputs are 1. So you can notice both the inputs are 1, so output will be 1. We know that 1 and 1, that is 1. So this is the AND gate. Now next question, determine the unspecified inputs for to each of the following gates if the output is shown. So now output is given to you, then what is the input? This is the AND gate. This is our AND gate and the output is 1. Then what is the input? If in the AND gate, if the output is 1, then the both inputs must be 1. Okay, so basically both inputs must be 1 because if the output is 1, if a b is equal to 1, where a comma b are boolean variables, if a b equal to 1, then I can definitely say that a is also 1, b is also 1. Correct? Okay, so this is what we can say. Next, this is OR gate. In the OR gate, if the output is 0, then definitely both the inputs must be 0. We know that if A or B, if that is 0, then what we can say? Then we can say that A is also 0, B is also 0. So in this situation, this is the OR gate. If the output is 0, then both the inputs must be 0. In this situation, this is the AND gate. And you can notice output is 0, one input is 1, then what should be the another input? That should be 0. Okay, very simple, because we know that if 1 and a is equal to 0, then definitely a must be 0. 1 and a, that is 0, then definitely what should happen? A should be 0. Next, this is the OR gate. Output is 1, one input is 0, then another input must be 1. Okay, because we know that if one input is 1, 0 plus a equal to 1, then definitely I can say that a is equal to 1. Okay, so this was an easy question. So we are starting with some easy questions. Let's see this question. Determine the output of each of these gates. So some gates are given to you and we need to tell the output. So tell me, this is AND gate. Again, the input is AA. Input is same, means AA. Then what is A dot A? A dot A, that is A. A and A, that is A. So output will be A. Okay. Next, this is the OR gate. This is the OR gate. Input is AA. Okay, both the inputs are same, so we know that A or A, that is A. So this output will be A. Here you can notice both inputs are different and this is the AND gate. So if both the inputs are different, A dot A dash, then that will be 0, because one of them must be 0, because both are complement of each other. This is A, this is A dash, so one of them must be 0. So definitely I can say that this output will be 0. Here you can notice both are different, both are complement of each other. This is A, this is A bar, so one of them must be 0, one of them must be 1, and this is OR gate. Okay, one of them must be 1 and this is OR gate, so output must be 1. So you can notice A plus A bar, we already know this is equal to 1. Here you can notice A dot 0, A dot 0 is 0, we already know. A plus 0, that is equal to A. Okay, A plus 0, that will be equal to A. Next, A dot 1, that is equal to A, and A plus 1, that is equal to 1. Okay, so these are some easy questions we are starting with. Okay, let's see this question. For each gate, determine the value of unspecified inputs. So tell me what is the answer for this question. Now this is the OR gate and total 4 inputs are there. OR gate and total 4 inputs are there. A, B, C, D, total 4 inputs we have. And this is given that A or B or C or D, that is equal to 0. Then what we can say? Then definitely we can say that all are 0. Okay, all must be 0, because you know that this is the OR gate. In the OR gate, if the output is 0, then all the inputs must be 0. Or I can say in the OR gate, output is 0 if and only if all the inputs are 0. And in this question, you can notice this is the AND gate, output is 0, then this input, at least one input must be 0. At least one input must be 0. This is the OR gate, output is 1, then at least one input must be 1. And this is the AND gate, output is 1, then all inputs must be 1. Okay, so these are some easy questions. Let's see this question. So these are some easy questions on OR gate, AND gate. Okay, now let's see this question. How many variables this expression has? So tell me how many variables are there in this expression. In this expression total, how many variables we have? So you can notice total number of variables, that is 4. So how many variables we have? That is 4. 4 variables we have, A, B, C, D. So total 4 variables we have, A, B, C, D. So the answer will be 4. How many variables we have? The answer will be 4. And how many literals we have? How many literals? So you can notice what is a literal. Literal is, remember, A is also literal and A bar is also literal. A comma A bar, both are literal. Similarly, B comma B bar, both are literal. Remember literal. So how many literals are there? When you are counting literals, then you should count all, okay, all of them you should count. You should count total how many literals are there. And what is a literal? A variable or its complement, that is a literal. Like A is also literal and A bar is also literal. Remember, this is variable. This is not variable. A bar is not variable. A is variable, B is variable, C, D, A, B, C, D. These are variables. But you can notice A comma A bar, both are literal. In this expression, how many literals are there? So you can notice total 4 literals here, then 2 literals here, then 3 literals here, and 1 literal here. So total how many literals? Total we have 10 literals. In this we have total 10 literals. Remember this point that literal, when you are counting literal, if I ask you A plus A plus A bar plus A, then in this expression how many literals are there? So number of literals, what that will be? Number of literals, what that will be? That will be 4. Number of literals will be 4, because what literal count tells you? This literal count, what this tells you? This literal count, what it tells you? It tells you what is the size of the expression. Remember, literal count tells us the size of the expression, indicates size of the expression. This indicates size of the expression. Okay, so remember this this literal count, this tells us, this indicates size of the expression. How big is your expression? Like this expression, in this expression we have total 4 literals we have. For example, this expression, in this expression we have total 2 literals. So literal tells you that what is the size of your expression. Remember, this and this both are same. A plus A, this is same as A. But here you can notice this is a big expression, this is a small expression. Here you have 1 literal. Here you have 1 literal, and okay, so you can notice here you have 1 literal and here you have 2 literals. So literal tells you, okay, what is the size of your expression. So in this expression total 10 literals you have. Let's see the next question. Next question. This okay. So this circuit is given to you. In this circuit, if A equal to B equal to 0, okay, and C equal to D equal to E is 1, then what will be the output? In this circuit, AB is 0, CDE that is 1. So you can notice CD that is 1, CD is 1, C is 1, D is 1, then this is AND gate, then definitely what is this? This is CD and this CD will be 1 and A is 0, CD is 1. Okay, CD is 1, A is 0 and this is OR gate. So this will be 1 because what is this? This is A or CD. This is A or CD. Next, what this will be? This will be the complement. So this will be 0. So this will be A or CD whole bar, whole complement. This is BE and you can notice B is 0, E is 1. B is 0, E is 1. This is AND gate. So if at least one input is 0, then output will be 0. So this is your BE and this will be 0. So finally this is OR gate. So this will be what? So this F, what will be F? F will be A plus CD whole bar, okay, A plus CD whole bar plus BE plus BE. So in this situation, tell me what will be output, what will be value of F? That will be 0. So 0 will be the final answer. Okay, for this question, I can say for this question number B, answer will be 0. And for this question number C, the answer will be this. Okay, for this question number C, what will be the answer? So you know that F is equal to A plus CD whole complement, A plus CD whole complement plus BE. This will be your expression for F. The question is asking Boolean expression for circuit output. So this will be the Boolean expression for this circuit output. The circuit output is F. For circuit output, this will be the Boolean expression. Okay, this question you can take as homework. This is a simple question. A circuit is given to you, and for this question, this truth table you have to fill it. Okay. So first you tell me what is the circuit, what is the expression for F? What is the expression for F? So you can notice that this input is A, this input is A, then this will be A bar because this is the inverter. We have NOT gate here, this is the NOT gate or inverter, so this will be A bar. So finally this will be what? This will be A bar B, and this is again inverter, so that will be A bar B whole bar. Okay, so the answer will be A bar B whole bar. This will be the answer. So your output of the function will be A bar B whole bar. Or you can apply the De Morgan law. Okay, apply the De Morgan law. We know the De Morgan law, that is A plus B whole bar, that is equal to A bar plus A bar B bar. Okay, this is the De Morgan law. In the De Morgan law, what happens? This OR will become AND. This will become AND. You can notice this A will become A bar. This A will become A bar. And this B will become B bar. Okay, so this is the De Morgan law. Similarly, we have AB whole bar. What is AB whole bar? That will be A bar plus B bar. Okay, these are the De Morgan law. You can apply the De Morgan law here. So we will get what we will get here. We will get A plus B bar. Okay, so your final expression will be A plus B bar, or you can say A bar B whole bar. Okay, very simple. Okay, so you can solve this question. This truth table you have to fill it out. This truth table you have to fill it. Okay, so you can check it out, and this expression you can write. So this question you can take as homework, and you can answer. Okay, what is this, like what is this expression, that you can answer in the comments. Okay, in the comment you can put what is this function F for this circuit, what is the expression for F. This you can put in the comments. You can put, okay, in the comments you can put. Let's see the next. Let's see this question. In this question, we are asking, indicate which of the following expression is in product of sum of product, neither. So tell me, which expression is in sum of product of sum, neither. So four expressions are given to you, and for these expressions, we have to tell which of these expressions are in product of sum of product, neither. So what will be the answer? So you can notice This expression, look at this expression. Is this in sum of product? Is this sum of product? Yes, this is sum of product. This is a product term. This is a product term. This is a product term. So this is sum of product. This is your sum of product expression. Okay, because you can notice sum of product. This is a product term. This is a product term. Okay, this is also product term. So what is a product term? Product term means product of literals. Okay, product of literals. Tell me about this one. This second one, is this SOP? Can I say this is sum of product? No, this is not sum of product. Can I say this is product of sum? This is not sum of product. Can I say this is product of sum? Tell me. Can I say this is product of sum? No, this is not a product of sum. This second is not a product of sum. This is not a sum term. Look at this. This is not a sum term. 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 What is a sum term? What is a sum term? This is sum. This is OR of literals. This is OR of literals. OR of literals. Okay. So for example, this is OR of literals. Like this is a sum term. This is also sum term. But remember, this is not a sum term. Like if I write a plus b, a plus bc, a plus bc, this is not a sum term because this is not a literal. This is not a literal. Okay. So sum term means OR of literals. We have already seen this in the class. So please don't make mistake. Okay. In the lectures we have already seen. So you can notice this is not in SOP. This is not in POS because this is not in product of sum because this is not a sum term. Remember, this is also not a sum term. Okay. Next, what about the third one? What about the third one? Yes, this is product of sum. This is product of sum because you can clearly see this is product of sum. I can write like this. See, I can write like this. So this is product of sum. A, B bar, I can write like this. A, B bar, okay. And you can notice this is sum term, this is sum term, this is sum term, this is sum term. So this third is POS. Okay, this is product of sum. And what about the last one? This is neither SOP nor POS. This is not in SOP, this is not in POS. Okay, is this clear? Please let me know. Okay, so remember, you can check it. So basically one is in product of sum, one is in sum of product, and two are neither. So you can notice the first one is SOP, the second one is neither, the third one is POS, and the fourth one is neither. Anyone has any doubt in this? So please don't make mistake. Okay, don't make mistake because remember, if I give you this A B C, A B C bar, tell me this, is this in SOP or POS? What can I say? This is SOP or POS. Which is correct for this expression? If I give you this expression A B C bar, then what can I say? Is this SOP or POS? Yes, this is both. This is both SOP and POS. If you look at this, if you look like this, if you look like this, then this is SOP. Okay, if you see, if you look like this, then it will be SOP. And if you see like this, then it is POS. Okay, so this is both. This expression is both in POS and SOP. Both are correct. But if I give you this, like A, B, C or D, E, tell me, what can you say about this? This is not in SOP. This is clearly not in SOP. And this is, can I say this is in POS? This is neither in POS. Okay, this is not in SOP. This is not in POS. Because remember, this is not a sum term. This is not a sum term. All these concepts we have already seen in the class. Okay, many examples we have already taken. Okay, so all these things we have already seen. So you can notice that in this total 4 expressions are given to you. First is SOP, third is POS, second and fourth are neither. Let's see this question. So tell me, this is SOP or POS? Which expression is this? SOP or POS? This one. Is this SOP or POS? Again, this is neither. This is not POS. This is not POS. And this is not SOP. Very simple. This is not POS. This is not SOP. Because remember, this is X plus Y bar. This is X plus Y complement. This is X plus Y complement. x plus y complement y plus z. So clearly this is not in POS, this is not in POS, this is not in SOP. This is neither, none of them. Okay, so don't make this mistake. So very simple. Now let's see this question. The question is asking for complements. Find the complements. Find the complement of each of the expression. So we have to find, basically we have to find the De Morgan law. Okay, you have to apply the De Morgan law. So tell me what will be the answer for this. A, B bar, C bar, whole complement. So what that will be? You can apply the De Morgan law. So this A will become A bar, this AND will become plus, this B bar will become B, and this C bar will become C. So this will be A bar plus B plus C. Okay. Next A bar plus B plus C plus D bar whole complement. What is that? That will be A. This OR will become AND. This will become AND. So this will be A, B bar, C bar, D. What is the answer for this? A bar plus BC complement. So remember this OR, this will become AND. See, this A bar will become A, this A bar will become A, okay. This OR will become AND, this OR will become AND. This BC, this will become B bar or C bar. So the answer will be A dot B bar plus C bar. What is the answer for this? Okay, so here this OR will become AND. So you can check that this I can say this OR will become AND. Now this OR will become AND. This A bar B bar, this will become A plus B, and this CD, this will become C bar plus D bar. Okay, so this will be the answer. And what about this option E? What is option E? In the option E, I can say that this plus will become AND. This OR will become AND. Sorry for that. So you can notice this AND. Look at this AND. This AND will become OR. Now this A will become A bar, and then what will happen? Then you will do the complement of this. You will do the complement of this. So the complement of this will be B. This OR will become and you will get C plus D bar. Okay. So answer will be A bar plus B bracket C plus D bar. Okay. Is this clear to everyone? Let me know. So very simple question. You have to apply the De Morgan law. We know the De Morgan law. What is De Morgan law? Any expression you have, any expression E plus F complement, then that will be E complement F complement. And you have EF complement, that will be E complement plus F complement. Okay. So this is an easy question. Now let's see this one. We have to find F complement. This F complement we have to find. F is given to you. So what is F complement? F is A bar B plus B bar C. So here you can apply the De Morgan law. A bar P plus B bar C whole bar. We have to find its whole bar. So what that will be? Very simple. See, very simple. This OR will become AND. This OR will become AND. Next, this A bar B, this will become A plus B bar. And you can notice this B bar C, this will become B plus C bar. Okay. So this is a very simple question. So your answer, this will be your F complement. So F complement will be A or B bar dot B or C bar. Let's solve this question. This question is saying that an expression is given to you, and for example, this function is given to you. Okay, so a function is given to you. This is not a minimum product of sum. This expression, this is not a minimum product of sum. We have to find minimum product of some expression. Minimum POS. For this F is given to you. For this F, X plus Y bar, okay, W or Z. So for this we have to find, for this F we have to find minimum POS. This minimum POS form we have to find. So for that we will use K-map. Okay, the best method is K-map. Is the question visible? So you can see this is the question. So now what we will do? Okay, this is the question, very simple. You can see the question. Now let's apply the De Morgan law for this question. So let's solve the question by De Morgan, by K-map. Okay, so we have three variables, four variables, x, y, w, z. First of all, actually, you don't have to apply the, basically, if you apply the K-map, then that will give you guarantee, that will give you guarantee that you will get minimum POS. So let's apply the K-map. Okay, so this function f is given to you on four variables. There are four variables in your function. Okay, let's apply the K-map. So here, this is the K-map, you can notice. This is the function f, and function f has total how many variables? Total four variables, x, y, w, z. Okay, so let's put x, y here, w, z here. So we have already seen that how to find the K-map. So this will be the, I can say, this will be the area of x, this will be the area of y, this will be the area of w, and this will be the area of z. Okay, now let's fill this. So first of all, this function is given to you like x plus y whole bar w plus z. So this function is given to you. So first you can apply the De Morgan law and it will become x bar y bar. Okay, so it will become x bar y bar, x bar y bar, and w plus z. You can find, so it will become x bar y bar w plus x bar y bar z. So can anyone tell me what are the true minterms? Can anyone tell me? Like we have x bar y bar w plus x bar y z. So from this function f we have, which has x bar. Okay, so this function f we have x y w z. This is the function x y w z, and for this function we have x bar y bar w, x bar y bar w plus x bar y bar z. So this is the function. Now tell me what are the minterms, like what are the true minterms, those minterms for which this function is 1. So which minterms for which this function will be 1? So let's find out. So you can notice very simple. Okay, I told you very easy method. If you want to find where, so this is your SOP. Now you can notice this is SOP form. This is SOP form. Now when you have this expression is in SOP form, now you can very easily find the true minterms. Those minterms for which the function will be 1, you can very easily find. You can notice that x, y, z, w. This x bar means 0. See, this x bar, this means 0. Y bar means 0. W means 1. And this z is not there. See, this z is missing. Here you can notice z is missing. So there will be two true minterms you will get. You will get 0, 0, 1, 0, and you will get 0, 0, 1, 1. So these two you will get. So which you got? You got minterm 2 and you got minterm 3. So these two minterms you got. And from here what you will get? From here you will get x bar means 0, y bar means 0. This w is missing. This is the order. Please remember, this is the order. Okay, so you should take care of the order. This is the order x, y, z, x, y, w, z. So here you can notice w is missing and this z is 1. So here two minterms you will get 0, 0, 0, 1, 0, 0, 1, 1. So this is your minterm 1 and this is your minterm 3. So finally for this function, what are the minterms? What are the true minterms for this function? The true minterms for this function are 1, 2, 3. These are the true minterms, I can say. For these minterms, your function value is 1. 1, 2, 3. For these minterms, your function value is 1. Okay. So now you can fill this function. Very simple. So when you fill this K map, then what will happen? This is, this is 0, 1, 2, 3. This is 4, 5, 6, 7. This is 8, 9, 10, 11, and 12, 13, 14, 15. Okay, so now you can fill this function. So our minterms, our true minterms are 1, 2, 3. So you can just fill 0, 1, 2, 3. Okay, so here our function value is 1. Here our function value is 1. But remember, we have to find POS. So we will focus on where our function value is 0. Our function value is 0 here, here, in all these cells. In all these cells, our function value is 0. Okay, because we need to find minimum POS. We have to find POS, and when we have to find POS, then we will focus on zeros. Okay, we will focus on zeros. And remember one more thing, when we have to find POS, then this area is x bar, this will be y bar, this will be w bar, this will be z bar. Okay, correct? All these concepts we have already seen. So because we have to find POS, so this area will be x bar, this will be w bar, this will be y bar, and this will be z bar. Now tell me, to find minimum POS, what area you will select? Which cube you will create? We will create, we can create size 8 cube, yes or no? We can create size 8 cube. So very simple, we can create this cube, we can create. So from this we can create one cube that we can create is this. We can create this cube, we can create. Okay, what is this cube? What will be the sum term for this cube? The sum term for this cube, which sum term you will get? So this is in the area of x bar. Okay, so this is in the area of x bar, so you will get x bar. Next, which sum term you will get for this cube? One next cube we can create is this. This is the next cube we can create. And for this next cube, what is the sum term we will write? We will write y bar. This is the sum term we will write. And next we can create this cube. Okay, for to cover this 0, we want to cover this 0. Then to cover this 0 we want to cover. So to cover this 0, what we can do? The only possibility is this. So this size 4 cube you can create. And this will be what? What is the sum term for this cube? For this, what is the sum term? For this, what will be the sum term? So for this, the sum term will be, this is in the area of, you can notice this is the area of Z or W. Okay, so this will be Z or W. So finally, your final answer, minimum POS, that will be X bar, Y bar, Z or W. This will be your final answer. X bar, Y bar, Z or W. Is it clear to everyone? This is the question. Okay. X bar, Y bar, Z, W. So you can find, you can check, you can, your answer will be this. Okay. If you take, see, I took this order, X, Y, W, Z. I took this order. If I take this order, then my answer, if I take this order, then my answer is this. My answer is X bar, Y bar, Z plus W. Okay, this is my answer. But if you take this order, then will your answer change? Please tell me, if you take this order, will your answer change? Will your answer change? Tell me. Will your answer change if you take this order? So your answer will not change. Okay. Whether you take this order or you take this order, the answer will not change. Answer will be same. Prashant, you can check it. Okay, you can take this as a homework. This thing you can take as a homework. So if you take this order W X Y Z, your answer will not change. Because remember, tell me one thing. When this order matters, please tell me when this order matters. Like A B C F A B C, and if I write B A C, when this order matters, can anyone tell me in which situation this order matters? This situation, in which situation this order matters? Tell me in which situation this order matters. This order matters only in case of, only in case of, okay, only in case of, I can say this notation. Only in case of this notation. Only in case of this notation. This notation. Only in case of this notation. Is it clear to everyone? See, only in this case, only in this notation, this order matters. When you have this notation, for example, if I say, like, okay, like if I give you two function, if I give a comma b equal to a plus b, and if I say b comma a equal to a plus b, both are same, there is no difference. See, if I say like this, f equal to a plus b, then if I say b comma a, then also this is same, there is no difference. There is no difference, the function is same. But remember, if I say like this, just okay, now consider this one. If I say FAB is equal to, that is 1 2 3, and now if I say FBA is equal to, for example, let's see another question, like let's see XOR B, A XOR B. If you take FB comma A, then that also same. Let's take some other thing. So A bar plus B. So if you take, okay, then also it will be same. There is no difference. If you have expression, Is this clear? So here you have expression. This expression you have FAB is equal to A bar plus B. Okay, FAB is equal to A bar plus B. Now if I change the order, that okay, both are correct. This is also F, this is also F. But remember, if I say that your FAB is equal to, if I say like this, that your FAB that is equal to, I can say 0, 1, 3. And here if I say 0, 1, 3. Now tell me, are they same? Here these are same, but here tell me, okay, here these are different. Here they are different. Is this clear? So remember, only in this notation, when you write this notation, when you write this mi, when you write this notation, in this notation the order matters. This order matters in this notation. So here in this situation, what will happen? What will be FAB? This FAB will be like this. Okay, you have this 0, 1, 3. Okay, so this FAB, let me call it F1, let me call it F2. So you can notice this is this is 0, 0, 0, 1, 1, 0, 1, 1. F1, what will be F1 and what will be F2? So F1 will be what? F1 will be 1, 1, 0, 1. This will be F1. And what will be F2? Tell me, what will be F2? F2 will be 1. Okay, you can notice. But note, focus on this one. This one here, basically, this one means 1, 0. And 1, 0 means BA bar. Okay, 1 means BA bar. So that will be here this one means 1, 0, and this, sorry, 0, 1. Sorry, 1 means 0, 1. So this will be 0, 1, and that means A bar B. And here this one means 1, 0, 1. This one means 0, 1, and that means B bar A. So this is the difference. Here you have A bar B, here you have B bar A. So this is the difference, you can check. Okay. So here I can say this will be 0, this will be 1. Anyone has any doubt in this? So this I told you in the class also. So this order matters only in case of this notation. Only in case of this order. This ABC, this BAC. This order matters only in case of this notation. When you have this notation, then order matters. In this case, order matters. But remember, if expression is given to you, this expression is given to you, now order does not matter. If I give you the expression, then order does not matter. If I give you the expression, for example, if I say f equal to a plus bc, if I say this, now this is same as whether you write, see, you can write it a comma b comma c, you can write b comma a comma c, you can write c comma a comma b. Okay, anything you can write, all are correct. There is no difference, all are correct. Okay, if I give you f equal to a or bc, if I give you this, then order does not matter because expression is given to you. But if I tell you this, f is equal to summation, okay, 0 to 5 6, if I tell you like this, if I give you this notation, if I give you this notation, now order matters. Now order will matter. Now remember, now if I write ABC, and if I write ACB, and if I write BAC, now if I write like this, then in all these things will be different. Now all these things will be different, and here all these things will be same. Is this clear to everyone? Please let me know. Is this clear? So if expression is given to you, this expression is given to you in terms of variables. This expression is given to you in terms of variables. Here all these things are same. It does not change. All these things are same. But if I give you this notation, if I give you, this notation if I give you, then the order matters. Then all these functions will be different. This function will be different from this function, and this function will be different from this function. All these functions will be different. Okay, please let me know if anyone has any doubt. Do you have doubt? Is it clear? Is this point clear? When this order matters, when this order does not matter. So this order matters only in case of this notation, this mi notation. In this notation, this order matters. In this notation. Okay, so let's move on. Now let's see some questions on counting the number of Boolean functions. Okay, so number of special type of Boolean functions, how to count. So let's see that. Let's see this question. Number of Boolean functions which satisfy f a comma b. So okay, we have to find those Boolean functions. We have to find those Boolean functions. We have to find f how many. Okay, how many Boolean functions we have which satisfy this property. Which satisfy this property. How many Boolean functions are there which satisfy this property? So remember, like okay, the question, what the question is asking, we have to count number of functions. We have to count number of functions which will satisfy this property. What is the property? The property is that f a comma b, that value is same as f a comma b bar. Okay. So for example, you have two variables. Let's understand this question. First, you understand this question. What this question is saying? This question is saying that on two variables a comma b, we have to count number of functions which will satisfy this property. This property is given to you. F a comma b is same as f a comma b bar. What this means? Please tell me what this means. This means f0 comma 0 should be same as what? Tell me. F0 comma 0, that should be same as what? That should be equal to what? Okay, this function is given. Basically, we have to count f a comma b. We have to count how many functions are there with which satisfy which satisfy this property. This property, what is the property? F a comma b is same as f a comma b bar. What it means? First, you understand what it means. It means that the value of function for 0 comma 0 should be same as value of function for 0 comma 1, and the value of function for 1 comma 1 should be same as value of function for 1 comma 0. This is the meaning. Okay, this type of function we have to count. This type of function means the value of function, for 0 comma 0. Okay, value of function for 0 comma 0, this means f a comma b. This means value of function for a comma b, this should be same as value of function for a comma b bar. So f0 comma 0 should be same as f0 comma 1. f1 comma 1 should be same as f1 comma 0. This is the question. First, you understand the question. If you understand the question, you can solve the question. Okay, so this is the idea, this property. Did you understand this property? Now the question is saying that how many functions are there which will satisfy this property. Okay, so tell me, if I give you this function, will this satisfy this property? This function f1, should we count this function? Tell me, this function f1 should we count? Should we count this function f1? So this f1, you can notice this f1 does not satisfy this property. So this f1 does not satisfy. Okay, this f1 we should not count. So should we count this? Should we count this function? This function should we count? Yes, this function will satisfy the property. What about this function 0 1 1 1? What about this function? This function will not satisfy the property. What about this function 0 1 1 0? What about this function? This function also will not satisfy the property. And what about this function 1 1 0 0? What about this? This function will satisfy the property. Okay, yes or no? f5, this function will satisfy the property. So remember, we have to count this type of function. Like this function we have to count, this function we have to count. So like this. So how many functions are there which will satisfy this property on two variables? F a comma b should be equal to f a comma b bar. This type of, how many functions are there? This type of number of functions. What is that? How many functions are there which have this property? So you can notice there are two variables. The question is very simple. There are two variables. So there will be 4 rows. 0 1 1 0 1 1. There will be 4 rows. Now the question is saying that the function value should be same here. Here the function value should be same. Okay. So for these two rows, the function value should be same. If you write x here, you should write x here. And if you write y here, you should write y here. Okay, So for these two rows function value should be same. For these two rows function value should be same. Now tell me, so very simple, now it is very simple. So okay, this x can be, remember this x can be 0 or 1, and this y can be 0 or 1. If I write 0 here, then I should write 0 here, because they must be same. And if I write 0 here, then I should write 0 here, because they must be same. So finally, what is the number of function? Two choices for these two rows. For the first two rows there are two choices, yes or no? For the first two rows, so for the first two rows there are two choices, and for the last two rows there are two choices. So finally four functions. So answer will be four functions. So this property will be satisfied by four functions. Is this clear? Total four functions will satisfy this property. Okay, this is the idea. Now let's see this question. What is the answer for this? How many functions will satisfy this property? How many functions will satisfy this property? F a comma b should be equal to f a comma b. How many functions will satisfy this property on two variables? So okay, every function will satisfy this property, right? Every function. Okay, so this property will be satisfied by every function. Every function will satisfy this property. This property is saying that f a comma b is same as f a comma b. So yes, every function will satisfy this property. And how many functions are there? You know, total four rows will be there. You can check. Okay, two variables. So there will be four rows. There will be four rows. And for each row, you have two choices. For each row, we have two choices. For each row, there are two choices. So total number of functions will be 2 power 4. Because for each row, there are two choices. Okay, so number of functions which satisfy this property, that will be 2 power 4, that is 16. Okay, is this clear? Because every function will satisfy this property. F a comma b is same as f a comma b. It simply means f 0 comma 0 is same as f 0 comma 0. F1 comma 1 is same as f1 comma 1. Okay, so answer will be 16. What is the answer for this question? What is the answer here? How many functions will satisfy this property? F a comma b is equal to f complement a comma b. Means f is equal to f complement. How many functions will satisfy this property? There is no function. No function. There is no function which will satisfy this property. Because remember, a function is never equivalent to f complement. A function is never equivalent to f complement. So there is no function which will satisfy this property. So f a comma b is equal to f complement a comma b. So how many functions are there? So that number of functions will be 0. Okay, so number of functions will be 0. There is no function which will satisfy this property, because there is no function which is equal to f complement. F is never equal to f complement. What is the answer for this question? Think about this question. What should be the answer here? The question is saying that f a comma b is equal to f a bar comma b bar. Again, this is very easy question. So what this question is saying? This question is saying that f0 comma 0 should be same as f1 comma 1. f0 comma 1 should be same as f1 comma 0. Correct? So this should happen. Okay, because the question is saying f a comma b should be same as f a bar b bar. So those functions we want those functions on two variables. We want those functions which have this property. This type of function we have to count. Okay, how many functions have this property? f00 is same as f11, and f01 is same as f10. So this type of function, there will be four functions. Again, there will be four functions, because remember, you have two variables. So for two variables, there will be four rows. We have total four rows, and the question is saying that these two rows must be same. See, okay, for here we have two choices. For here we have two choices. But remember, for here we don't have any choice. If I put, okay, I can say for these two rows, what I can say for these two rows, this row and this row, for these two rows we have two choices. For these two rows we have two choices. Either both will be 0 0 or both will be 1 1. Similarly, for these two rows we have two choices. There are two choices for these two rows. Either both will be 0 0 or both will be 1 1. So there are two choices for these two rows, and there are two choices for first and last row. So finally number of such function, that will be total 4 functions are there. Okay, that will be 2 into 2. So total 4 functions we have. What is the answer for this question? This is very nice question. So tell me what is the answer. Please understand the function. If you understand the function, you can answer it. If you don't understand the function, you will not be able to answer. First, you understand the function. Which function is given to you? So what is the answer for this function? FAB is same as F complement AB bar. So please understand this function. This function is saying FAB is same as F complement AB bar. How many functions are there? This type of functions are there. How many? No, I changed two variables only. Sandeep, only two variables. That was a mistake. I corrected it. Now tell me here. How many functions have this property? Before this function, you tell me this point. If I say f a comma b is same as f bar a comma b, that what it means? What this means? Can anyone tell me what this means? Can anyone tell me what this means? This means that f a comma b is different from f a comma b. Agree or not? Yes or no? This means f a comma b is different from f a comma b, because what this means, look at this. What this means that for 0 comma 0, for 0 comma 0, this f for 0 comma 0, this should be same as f complement for 0 comma 0. Okay, so you know that x bar. So okay, what this question is saying, the question is saying that f a comma b is same as f complement of a comma b. That means these two should be same. Or I can say these two should be same. Or I can say f a comma b is different from f a comma b. And this is not possible. And this is not possible. Similarly, this is not possible. Are you getting the point? Tell me. Did you understand this? See, very simple point. What I am saying is, if I give you, for example, if I say f a comma b is same as f complement a comma b bar, what this means? Can anyone tell me what this means? F a comma b is same as f complement a comma b bar. See, this is your function a comma b, 0 0 0 1 1 0 1 1. You take some function. You take some function f. Take any function f. Now, the question is saying that f a comma b means this 0 comma 0. Let's assume this is 1. Let's assume this is 1. Then this should be same as f a comma b means this 0 comma 0. This should be same as f complement 0 comma 1. F complement 0 comma 1. Okay, f complement 0 comma 1. And this I can write as f 0 comma 0 should be different from f 0 comma 1, because this f0 comma 0, f0 comma 0, this should be same as f complement 0 comma 1. Okay, so this and this, they should be same. They should be same. Then it automatically means this will be 0. This implies this implies this. Yes or no? Tell me. Is this clear? Are you getting this point? F a comma b is same as f complement a comma b bar. What this means? F0 comma 0 is same as f complement 0 comma 1. Okay, so you can notice f0 comma 0, if that is 0, if that is 1, then f complement 0 comma 1 should be 1. And if this is 1, then this will be 0. So what I'm saying, I'm saying that f0 comma 0 should be different from f0 comma 1. This is the idea. So I can say, if I say f a comma b is same as f complement a comma b bar, then this is same as, this thing is same as, this thing is same as f a comma b is different from f a comma b bar. Okay, so both these things are same. So this is the question. The question is saying that f a comma b is same as f. Okay, so this thing is same as this thing. I can say f a comma b is different from f a comma b bar. So this type of functions are how many? F a comma b is different from f a comma b bar. So this type of function we want. We want this type of function 0 0 0 1 1 0 1 1. Okay, so we want this type of function which such that f a comma b is different from f a comma b bar. Means these two must be different. Okay, and these two must be different. So if I write, remember, if I write x here, then I should write x bar here, and if I write y here, I should write y bar here. So you can notice there are two choices for these two rows. For first and second row, for these two rows, there are two choices. There are two choices, because if I write 0 here, then I should write 1 here, and if I write 1 here, then I should write 0 here. So there are two choices. And similarly, for these two rows, there are two choices. For these two rows, there are two choices. Okay, if I write 1 here, I should write 0 here. If I write 0 here, I should write 1 here. So finally, such functions, what is the number of such functions? So that will be 4. 2 into 2, that will be 4. So total 4 functions have this property. Total 4 functions have this property. Is it clear? Let me know. Avni, did you get it? Did you understand this? Like this function, look at this function. This will satisfy this property. Just look at this function, f a comma b 0 0 0 1 1 0 1 1, and look at this function 0 1 1 0. Look at this function. This function will satisfy this property. This f, you can check, this f has this property that f a comma b is same as f complement a comma b bar. You can check. This function has this property. This function has this property that f a comma b is same as f complement a comma b bar. Means f 0 comma 0 is same as f complement 0 comma 1. You can check f 0 comma 0. F 0 comma 0 is same as f complement 0 comma 1. So you can notice both are same. You can notice both are same. Similarly, f 0 comma 1 is same as f complement f a comma b is same as a comma b bar. So f 0 comma 1 is same as f complement 0 comma 0, and you can notice both are same. Okay, f 0 comma 1 is same as f complement 0 comma 0. So you can notice both are same. Let me know, did you get it? Did you understand this question? This is a very nice question. Tell me, did you understand this question? Let me know. So what I'm saying is like this. Okay, so this is the final conclusion. What I'm saying is like this. If I say that f a comma b comma c bar, or maybe c, is equal to f complement a comma b bar comma c bar, then what this means? This is same as, this is same as, this is same as f a comma b comma c is not equal to f a comma b bar c bar. Tell me, did you understand this? F a comma b comma c, this is equal to f bar a b bar. This is equal, means f is equal to f abc is equal to f bar a b bar c bar. This is same as f abc is not equal to f a b bar c bar. So tell me, how many such functions are there? Can you tell me? What is the number of functions? What is the number of functions? How many functions are there with this property? how many functions f, which have this property, f a b c is equal to f complement a b bar c bar? How many such functions are there? So this question you can change. You can change, this is same as, you can say this is same as f a b c. f a b c should not be equal to f a b bar c bar. Okay, f a b c should not be equal to f a b bar c bar. And remember, there are three variables. So because there are three variables, there will be total 8 rows. So the question is saying that f, remember, f000, this type of function we want. We want this type of function. This should be not same as, remember, f000. f000 should not be same as f011. These two must be different. Means this 000 and 011. These two must be different. If this is x, this should be x complement. Okay, is this clear? Similarly, 001. Similarly, f001. This should be different from f010. So this 001, this should be different from these. These two must be different. If this is y, this should be y bar. If this is y, this should be y bar. And similarly, 100, this should be different from 111. They must be different. If this is z, this should be z bar. And similarly, 101, this should be different from 1. Okay, one. So these two must be different. If this is a, this should be a bar. So tell me how many functions are there. So you can see that for these two rows, remember, for these two rows, like, okay, for this x we have two choices, for this we have two choices, for this y we have two choices, for this z we have two choices, and for this a we have two choices. So there are these many choices. For x two choices, for y two choices, for z two choices, for a two choices. So final answer will be, how many functions are there? So number of functions, what that will be? That will be 2 into 2 into 2 into 2, and that will be 2 power 4. Total 16 functions we have which will satisfy this property. This property will be satisfied, f abc equal to f complement a b bar c bar. This property will be satisfied by 16 functions. Total 16 functions are there which will satisfy this property. Okay, so tell me the answer for this question quickly. Very quickly tell me the answer for this question. On two variables you have this function, f ab should be equal to f bar a bar b bar. Remember, this is same as f a b should be different from f a bar b bar. This is the question, correct? So the question is quite simple. Now these type of questions are very easy for you, yes or no? Now this type of questions are very easy for you, yes or not? Please tell me. These questions are very easy now, because this question is saying that FAB is equal to F bar A bar B bar. So I can say that FAB is different from FA bar B bar. So basically it's like this. Okay, you have two variables 0 0 0 1 1 0 1 1. Then remember your function value. If this is x, this should be x bar. If this is y, this should be y bar. Okay, like if this is 0, this should be 1. If this is 1, this should be 0. So this type of functions you want. FAB should be different from FA bar B bar. These two must be different. These two must be different, and these two must be different. So how many functions? So number of Boolean functions, that will be 4. 2 power 2, that will be 4. And what is the answer for this? What should be the answer for this? FABC equal to FA bar B bar C bar. FABC, that is equal to FA bar B bar C bar. What is the answer for this? So for this answer will be 2 power 4. You can check, total 16. Okay, you can check, because FABC, remember it's like this. For 0 0 0, for this row, remember this row must be same as this row. These two rows must be same. These two rows must be same. So these two rows must be same. This and this, they must be same. Similarly, 0 0 1, this should be same as 110. These two must be same, and so on. Okay, so like this, if you do, then finally you will get answer will be 16. You can check it out. Can you notice what is this function? This function, if you notice, this is a special function. FABC is same as FA bar B bar C bar. What can I say this function? What name I can give to this function? This function is saying that the first row must be same as last row. The second row must be same as second last row. So this function is basically what? This is your palindrome function. Yes or no? This is the palindrome function because the first row must be same as last row. The second row must be same as, no, this is palindrome function. This is not self dual. This is not self dual. Abhishek, Mayuk, this is not self dual. So this is palindrome function. FABC is same as FA bar B bar C bar. So this type of function, this is your palindrome function. Next, what is the answer for this question? Quickly tell me. FABC is different from F bar A bar B bar C bar. What this means? So remember, this simply means I can say that this is your function. FABC is different from FA bar B bar C bar. Okay, FABC is different from FA bar B bar C bar. Yes or no? This is your self dual function. This type of functions are self dual function. We have already seen this function is called self dual function. Self dual function means FABC should be different from FA bar B bar C bar. They must be different. So this is your self dual function. Like this, you have ABC. These are the three variables. So this 0 0 0, this should be different from, these two must be different. Okay, this and this, these two must be different. And similarly these two must be different. Like if I say 0 0 1 1 1 0, these two must be different. So this type of functions are called self dual functions. FABC is different from FA bar B bar C bar. This type of function is called self dual function. So remember, there are, okay, how many definitions we have seen? Self dual function, self dual function, all these concepts we have already seen in the class. All these concepts are actually we have already seen. I am just repeating these concepts. Self dual function, self dual function means FABC, that should be different from FA bar B bar C bar. Another definition, so either I can call it self dual, or I can call it, another definition is like this: FABC should be same as F bar A bar B bar C bar. Okay, so these three definitions are same. All these three things are same. Okay, in the exam they can give you any definition. See, they can give you this definition, or they can give you this definition, or they can give you this definition. All these definitions are same. FABC should be different from FA bar B bar C bar. These must be different. Let's see this last question. FABC is same as F bar ABC. How many such functions are there? What is the number of such functions? What is the number of such functions? Number of this type of function. FABC is same as F bar ABC. That will be 0. This type of functions are not possible. Because what this means? What this means? This means FABC is different from FABC. FABC is different from FABC. And this type of function are not possible. This type of functions are not possible. So number of such functions is 0. Okay, so is this clear? Now let's see this one last thing. Let's see this last thing, that is dual and complement. How to find dual from truth table? See, you know how to find dual from, if you have this expression. Okay, if I give you some expression, like, okay, if I give you some expression, some function I give you, and if this function has these things, like variables, you have variables, you have literals, you have 0, you have 1, and you have and, comma, or. If this type of function I give you, then you can very easily find the dual. Yes or no? From this type of function, you can very easily find the dual. Correct or not? Because this function uses only and, comma, or. So you are using only these things you are using, and, comma, or. So if your function I give you in this format, if I give you the function, then you can very easily find the dual. And the dual you will find like this. Literals don't bother. Don't bother the literals. So literals will be same. Don't change the literals. The literals will be same. Don't change the literals. But this 0 will become 1. This 1 will become 0. This plus will become and this and will become plus. So if I give you a function in this format using these things, if your function expression, if your expression has and or, only these things your expression has, then you can very easily find the dual. Very easily you can find the dual. Okay. And similarly, you can also find the complement. If you want to find the complement, that also you can find very easily. Okay, what you will do? This A will become A complement. This B will become B complement. This A bar will become A. This B bar will become B. This 0 will become 1. This 1 will become 0. Or will become and will become or. So this you already know. But tell me, okay, from truth table how to find complement, from truth table how to find dual. This is the question. This is my question. See, if I ask you what is the dual of this, then you can find very easily. What is the reason you can find very easily? Can anyone tell me? What is the reason you can find dual very easily? What is the reason? Tell me. What is the reason you can find dual very easily? Like f dual you can find very easily for this function, for this expression. For this expression you can find dual very easily. When what is the reason? Because this function is using only and, comma, or. Only the only operations that you are using, that is and, comma, or. Okay, this expression has and, so this expression has and, comma, or, nothing else, and, comma, or. So you can find dual very easily. What you will do? Don't change the literal. The literal will be same, m will be same. This plus will become and, this n bar plus p bar. Okay, so this will be your dual. And what will be f complement? What will be f complement? F complement, what that will be? This m will become m bar, this plus will become and, this will become and this will become plus p. Okay, so quite simple. M bar n plus p. Okay, but remember, if I give you this expression, please understand, if I give you a truth table, like if I give you a comma b, some truth table I give you, from truth table you can very easily write the complement, right? This is your truth table. So let's assume this is the truth table. And if I give you a function from truth table, how to write f complement? Can you tell me? From truth table, how to write f complement? From truth table. Like from truth table directly, how will you write complement? How will you write complement from truth table? Very easily. 0 will become 1, 1 will become 0, 0 will become 1, 0 will become 1. So very easily you can find the complement from the truth table. But from the truth table, how to find dual? Like how to find dual from the truth table? Anyone? We have already seen the proof. With the proof we have seen in the class. In the lecture we have already seen the concept. From the truth table you can very easily find the complement. See, the complement you can find very easily from the truth table. It is very easy for you. Okay, but from the truth table, how to find dual? Like how to find this dual? How to find this dual from the truth table? How to find that? Yes, in the class we have already seen how to find this. With proof, I told you the proof also. And how to find this? Very simple. Okay, just reverse this complement. See, this truth table, if you notice, this is in the standard order. Is this truth table in the standard order? Tell me. Is this truth table in the standard order? Yes, this is in the standard order. This truth table is in the standard order. Correct? So when your truth table is in the standard order, then how to find the dual? That will be reverse of this complement. Just reverse of this complement. This will be the dual. So your f dual will be 1 1 0 1. What I am saying, please understand what I am saying. I am saying like this. If I give you some f, this f you can find like a b c d, or I can say this is a0, this is a1, this is a2, this is a3, because this is the standard truth table. This truth table is standard, you can notice. So this truth table is in the standard format, 0 1 2 3. This is in the standard format. This is your function f. Now you can very easily find f complement. From this function you can very easily find the complement, that will be a0 complement, a1 complement, a2 complement, a3 complement. And how to find f dual? How to find f dual? Just reverse it. Just reverse this complement. This f complement you reverse. F complement you reverse. Just reverse this f complement. This will be your f dual. Did you understand? Very simple. Okay. So this is very simple. F complement you can find, from f you can find f complement, and then you can reverse it. Just reverse it, means just reverse it. So basically a3 complement, a2 complement, a1 complement, a0 complement. Okay. This will be your f dual. This is how you can find f dual. Very easily you can find f dual. And this, and what is the proof we have already seen? Proof we have seen in the class. I told you, proof seen in class. In class. So in class we have seen what is the proof of this. So I will not tell you the proof now. In the class we have already seen this, the proof we have seen. Okay, but the idea is very simple, that f dual will be, you find the f complement and then you reverse it. Okay, you reverse it, very simple. So if I give you any function, for example, if I give you 0 1 1 0, then what will be f dual? Now you can very easily find f dual. What will be f dual? Okay, complement reverse. First you take complement, then you reverse. First you take complement, then you do reverse. So it will be 1 0 0 1. Yes or no? First you take complement and then you reverse. So your complement will be, see, your complement, what will be your complement? The complement will be 1 0 0 1. Now you reverse it. This will be the complement. Now you reverse it. So this will be the dual. Okay, you can check. For this function, what is this function f? What is this function? This function is a XOR b. F is a XOR b. For this function, the complement is a XOR b and the dual is also a XOR b. Okay, for this function, the complement is also a XOR b and the dual is also a XOR b. So like this you can do. Any function I give you, you can handle. If I give you 0 0 0 0, what is the complement? For this function, what is the dual? What is the dual? What is the complement? Okay, dual means just take the complement and reverse it, and reverse this. So reverse this, that will be your dual. So you can notice here, for this is your function 0, and you can notice f complement is 1 and f dual is also 1. So can you notice for this function f complement and f dual are same? Can you notice for this function, f complement and f dual are same? And for this function also f complement and f dual are same. Can you notice both are same? F complement and f dual are same. But for this function, notice for this function, f complement and f dual are not same. Can you notice f complement is not same as f dual for this function? For this function, f complement and f dual, they are not same. Yes or no? But you can notice for this function a XOR b, for this function f complement and f dual are same. For this function f complement and f dual are same. And what about this function? If I give you this function, what about this function? Can I say for this function what will be f? Your f is 1. What will be f complement? F complement will be 0. F dual also will be 0. You can check. F complement will also be 0 and f dual will also, okay, f dual, that will be reverse of complement. Reverse of complement, reverse of complement. So you can notice for this function also they are same. But what about this function? For this function, can I say they are same? Like 0 1 1 1. What is f complement and what is f dual? F complement is very simple, 1 0 0 0. Now you reverse it. If you reverse it, then you will get F dual. For this function F, what is your function F? Your function F is A or B. For this function F complement is different from F dual. For this function you can notice F complement is different from F dual. Yes or no? F dual is AB. F dual is AB. And what is F complement? F complement is A bar B bar. Okay, F dual is AB. F complement is A bar B bar. Is this clear? So this idea, please tell me, this idea is clear to everyone or not? How to find the dual? So find dual of a function. You can very easily find. Okay, if I give you anything, if I give you, so very simple, you can just check it out. So what I'm saying is, from truth table, how to find dual? Very simple. Remember, this is very important also. This is very important also, that if I give you a truth table A, B, C, let's assume in the standard order. If I give you this truth table in the standard order, like 0 0 0 0 0 1 0 1 0 0 1 1, and then 1 0 0 1 0 1 1 1 0 and 1 1 1. If I give you this truth table in the standard order, like 0 1 2 3 4 5 6 7, if I give you this truth table in the standard order, this truth table is in the standard order. If I give you a truth table in the standard order, then if you have any function, let us assume you have any function a0 a1 a2 a3 a0 a1 a2 a3 a4 a5 a6 a7, then what will be F complement? Tell me what will be F complement? Or I can ask you directly F dual. What will be F dual? Tell me. If you have this function, then what will be F dual? F dual will be complement reverse. You take complement and then you take reverse. So it will be complement reverse. You take complement and then you take reverse. First you take complement and then you take reverse. So this will be the F dual. Okay. So you take complement. First you find complement. Complement will be like this: A0 bar, A1 bar, A2 bar, and so on, A7 bar. Okay. So you take complement and then you reverse. That will be your F dual. Now tell me, what is the F dual of this function? I give you this function F A comma B. This function I give you 0 comma 1 comma 3. Then what will be the F dual? See, first you find out F complement. First you find F complement. What that will be? F complement, what that will be? You can notice function is 1 here. Your function is 1 here. So your F complement will be 1 here. Yes or no? Your function F is 1 here. For these things, F is 1. For these things. Then automatically for this, your F will be 0. Or I can say for this, F complement will be 1. Okay, for this I can say F will be 0, or I can say F complement will be 1. So I can say F complement will be like this. Now you find F dual. Now, how to find F dual? Tell me, how to find F dual? F dual means complement and then reverse. So remember, F dual will be what? So first you find complement. This will be your complement, and then you reverse. What is reverse of 2? Like when you reverse, then what this 2 will become? This 2 will become 1. So this will be your F dual. Actually, this we have already seen in the class. What I am saying like this. See, when you reverse, just focus here. If I give you ABC, let me assume I give you ABC. Okay, this is 0 0 0. Okay, let's assume this is 0 0 0. What is this value? This value is 0. Now you can notice, if this value I say A0, let's assume your function value is A0, then your F complement value will be what? Your F complement value will be A0 bar. But you notice that what will be the reverse of this 0? Like what will be the reverse of this 0? The reverse of this 0, that will be 7. The reverse of this 0 will be actually 7. I can say when you reverse, then this A0 complement will go here. See, when you reverse, then this A0 complement will go here. This will go here. This A0 complement will go here. And you can notice that this A1 complement will go here. This A1 complement, it will go here. So, okay, this A1 complement will go here. So, what is the reverse? Like, if I ask you, basically, this is the question. Okay, very simple question. Let's assume if f a let's assume f a b c, and this is 1 when, if f a b c is 1 when, I can say for this is 1 for 2 for when m2. Okay, means for this min term this f a b c is 1. Okay, for this min term for m2 this is 1. Then what can you say? Then f complement will be 0 for m2. Yes or no? F complement will be 0 for m2. And what can you say about dual? See, for m2 f complement will be 0. If f complement is 0 for m2, then f dual will be 0 for what? Because f complement is 0, you will reverse. What you will do? You will do reverse. If f complement is 0 for m2, then f dual will be 0 for m5. You will remove from 7. Yes or no? The reverse of 2, that will be 5. The reverse of 2, that will be 5. Because you will remove from 7. Is this clear? Like if your function, very simple, your function is for this 0 1 0, for this 0 1 0 your function is 1, then your f complement will be 0. F complement will be 0, but f dual, if you notice f dual, then this 0 will go here. This 0 will go where it will go? It will go 1 0 1, means 5. Yes or no? It will go. Okay, because when you reverse, this f complement you can find, and when you reverse, this will be your f dual. The same question I can repeat. Let me ask, let's assume that f if f complement is 1 for for m3, then what can you say about f dual? This will be m for 1 for what? F complement is 1 for m3, then f dual will be 1 for m4. Yes or no? So finally I can say that basically remember reverse. Remember I can say reverse of mi. What is that? Reverse of mi. When you reverse, then this reverse of mi, that will be m 2 power n minus 1 minus mi. Like for example, if I ask you what is the reverse of m2, if I ask you what is the reverse of m2, then that will be 7. That will be 5. So that will be 7 minus 2. If I ask you reverse of m1, then that will be 7 minus 1. So here you can notice this will be m5, this will be m6. Please tell me, did you get it? Did you understand this whole thing? So let me give you the conclusion. Okay, now we are going to see the conclusion, and this is the final conclusion. If you have a function, if you have a function on n variables, and if this function is like this, if these are the min terms, if these are the min terms, like I can say, if your min term is, for example, let's assume your function is 3 variable. Let's assume your function is 3 variable abc. Your function is 3 variable and 0 1 3 6. Let's assume this is your function. Then what will be f complement? Tell me what will be f complement? F complement will be what? If this is your function, then your f complement will be, because here your function is 1, then your f complement will be 1 as 0 1 2 3, that will be 2 4 5 7. This will be your f complement. And what will be f dual? What will be f dual? That will be reverse of f complement. F dual will be reverse of f complement. F dual is reverse of f complement. So what? Okay, what is the reverse of 2? that will be 7 minus 2. Reverse of 4, that will be 7 minus 4. Reverse of 5, that is 7 minus 5. And reverse of 7, that is 7 minus 7. So what is your F dual? Your F dual is 0, 2, 3, 5. This will be your F dual. So your F complement is this, your F dual is this. Did you understand? See the question, okay, very simple. If I give you this function, let's assume I give you this function, then what will be F complement? This function is given to you, F complement will be what? F complement will be 3. And what will be F dual? F dual means reverse of F complement. Reverse of F complement. So reverse of 3 will be 4 minus 3. Sorry, reverse of 3, that will be 3 minus 3. So that will be 0. Reverse of 3, that will be 0. So this will be your F dual. Okay, this will be the F dual. Like for example, if I give you a function f a b c, any function I give you, let's assume this is the function 0 1 6, then what will be F complement? What will be F complement? That will be F complement, that will be, this is 0 1 6, so F complement will be 2 3 4 5 7. This will be F complement. And what will be F dual? What will be F dual? F dual will be, you remove this from, you remove this from 7, 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 and you remove this from 7. This will be your F dual. Anyone has any doubt in this? How to find F dual? From the truth table, I told you. If you have truth table, how to find? I told you. Just take the complement and reverse. Now I am telling you from directly, like directly how you find. How to find it directly. This is what I am telling you. So very simple. If you want to find dual, then first you find complement. Finding complement is very simple. Because for these f is 1. F is 1 for these minterms. So your f complement will be 1 for the remaining minterms. Okay, f is 1 for these minterms. So your f complement will be 1 for the remaining minterms. And from f complement you can find f dual. All you have to do, okay, all you have to do, just remove everything from 7. Remove everything from 7. Clear? Let's see this question. This is an interesting question. So tell me the answer for this. F is a Boolean function in 5 Boolean variables. There are 5 Boolean variables. F, A, B, C, D, E. And this function is given like this. This is the function given. Let D be the dual of function f. So D is the dual of this function. Which of the following is not a subset of true minterms of D? Which of the following is not a subset, of true minterms of D? So first you find the true minterms of D. See, f is given to you, right? This function f on 5 variables. There are 5 variables, so this function f is given to you. 0 1 7. So this function is like this is given to you. What will be f complement? Can anyone tell me? For this function, what will be f complement? Let's find out f complement for this function. Let's find out f complement for this function. So what will be the f complement? First you find f complement. What that will be? F complement will be remaining. All the remaining values. All the remaining values. This is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, then 18 till 28, and then 29 30 31. Okay, so this is the complement. Yes or no? F complement will be this 18 28. Okay, so this will be F complement. Now you can find F dual. Now you can find F dual. F dual is very simple. You will remove this from where? F dual means reverse of F complement. Yes or no? F dual is reverse of F complement. that is reverse of f complement in truth table. In truth table, that is the reverse of f complement. F dual is reverse of f complement in truth table, reverse of f complement. So this is your f complement. So what I will do, this I will remove from 31. This I will remove from 31. So I will get 31 minus 2. This I will remove from 31 like this. So this I will remove from 31. So what I will get? From 31 I will remove. So 27. Okay. This I will remove from 31. So I will get 26. I will remove from 31. I will get 25. Okay. Like this and so on. This I will remove from 31. 3. This I will remove from 31. Okay. From 31 I will remove this. Then what I will get? I think I will get 13. Okay. So like this will be F dual. So F dual will be like this. 3 to 13. F dual will be, this will be the F dual. Finally I can say F dual is what? That is 3 to 13. Okay. From 3 to 13, and then for 13 you will get 18. So you will get 18, you will get 18, 19, 20, 21, 22. Okay. So you will get these, and then you will get 25, 26, 27. Then you will get 25, 26, 27, and then okay, that is 2, 3, 4, 5, 6. Okay, so that will be 28, 29. Okay, so this will be your answer. Your F dual is this. Finally, your F dual is basically this. Now you can check the answer. So what is the answer? This is saying which of the following is not a subset of true minterms of D? 7, 8. Is this a subset of true minterms of D? 7, 8. 7, 8. Yes. From 3 to 13 there is no problem. So okay, so the answer will be option D. Because 29, this is not a true minterm in FD. Okay, so sorry, 29 is there. Sorry, 29 is there, but which is not there? 29 is there, 24 is not there. Okay, 24 is not there. You can notice 24 is not there. So 24 is not there. So answer will be option D. For this question, answer will be option D. Okay, answer will be option D. Did you understand this dual? Because many students, they do not understand the concept of dual actually. So we in the class we have seen, I told you what is the concept of dual, from where this dual is coming. Now did you understand how to find dual? Any expression I give you, if I give you any expression, then how to find dual? Any function I give you, let for example just take this question, last question, let's see this. Okay, like if I give you 0, 3, then what will be f complement? What will be f complement? F complement will be 1, 2. F complement will be 1, 2. And what will be f dual? F dual, what will be f dual? You remove this from 3. Okay, you remove this from 3. Can you notice these are same for this function? For this function, can you notice they are same for this function? For this function, f dual and f complement are same. Okay. Now, what is a self-dual function? What is that? In the class, we have seen what is a self-dual function. Self-dual function is basically, I told you, f a b c. This should be different from f a bar, b bar, c bar. This type of function is called self-dual. This type of function are dual of itself. Means if you take f and you take f dual, they will be same. Okay, this type of function is dual of itself. Means self dual. Means f is equal to f dual. This is the definition of self dual. F is equal to f dual. So these are self dual function. F abc equal to f a bar, b bar, c bar. Remember which is self dual? Tell me which f is self dual? Which f is a self dual? Let me ask you some questions. Which f is self dual? First, where f is equal to f dual? Second, where f is equal to f complement. Third, where f dual is equal to f complement. Fourth, which f is self dual, which f is self dual. Fourth, so first you tell me about these one, which f is self dual. First you tell me about these three, tell me the answer for these, which of them is self dual. This is the definition of self dual, this is the definition of self dual. This is never possible, this is never possible, and this is not self dual, this is never possible, this is never possible, and this is not self dual, this is not self, this is not the definition of self dual, this is not the definition of self dual. Remember, f dual is same as f complement, this is not the definition of self dual. For example, look at this function, look at this function f ab equal to a XOR b. Look at this function, this function is not self dual, this is not self dual, this function is not self dual, because what is f dual? F dual is ax nor b, this is f dual, and f complement is also ax nor b, so they are same, they are same. But you can notice this is not self dual, this function is not self dual, because f is not same as f dual, f is not same, f is not same as f dual. Okay, tell me about this one, like which function is self dual. Some more questions, is this function self dual? Like if I say f a comma b comma c, that is same as f complement a b a bar b bar c bar, is this self dual? F a b c is same as f is not same as f complement a bar b bar c bar. Next, f a b c is the same as f a bar b bar c bar. Which of them is self dual? Tell me, which of them is self dual? F a b c is same as f a bar c b bar c bar, this is not self dual, this is not self dual. Okay, this is a not a self dual, you already know this is not self dual. So which is self dual? F a b c, and these two things are same. Actually second and third, they are actually same, yes or no? Second and third are actually same, they are actually same. F a b c is not same as f complement a bar b bar c bar. Okay, so second and third, they are same, they are exactly same. Yes, this is self dual, this is self dual. Okay, yes or no? This first one, this is self dual. Remember, self dual function is this. For example, if I do this, now this will become self dual. Now what is the answer? Now this will become self dual, and these two are same. This first and third, they are same. 1 comma 3 are actually same. Option 1 is same as option 3. Again, this is not self dual. Okay, tell me, is this clear? Please don't make this mistake. Self dual means f a b c is different from f a bar b bar c bar. Any doubt so far? Is there any doubt in this? Self dual, complement, all the variations we have seen, every variation I have told you. What is the dual of NAND? Tell me, what is the dual of, like for example, let's see some functions on two variables. On two variables I am writing some functions, and you tell me what is the dual. Two variables, some functions I am writing, and you tell me the dual, like what is the dual. So tell me, first tell me what is the dual of 0. Here I am writing function, and here I am writing dual of f. So what is the dual of 0? You know that 0 will become 1. 0 will become 1 in the definition of dual. We have seen this, 0 will become 1. Okay, so for 1, next, what is the dual of a? What is the dual of a? That will be a. What is the dual of a bar? That will be a bar. What is the dual of b plus 1? What is the dual of b plus 1? Dual of b plus 1? That will be b dot 0. So you can notice this is 1, and you can notice this is 0. So that is correct. You know this function is 1, this function is 1, this function is 1, this function is 1, so the dual will be 0. Tell me for this function what will be the dual. If I give you what is the dual of f for this ab, what is the dual of ab? That will be a plus b. For a plus b the dual is ab. Now tell me what about XOR? What about XOR? A XOR b, what is the dual? The dual is a XOR b. What is the dual of a XOR b? That will be a XOR b. Next, tell me what is the dual of this function, like NAND. This is your NAND. A NAND B. What is the dual of A NAND B? You can check it. That will be A nor B. The dual will be A nor B. See, if you see A NAND B, what is this? This is A NAND B. So this is actually A bar plus B bar. So what is the dual? What is the F dual? So from this you can find the F dual. This plus will become dot. So this will become A bar B bar. And this is nothing but NOR. This is your NOR. Okay, so for NAND, NOR will be the dual. For NOR, NAND will be the dual. Okay, so like this you can do. All these things you can do. Any function I give you, you can handle. Okay, any function. Let's see this. This is NTA NET question. This is NTA NET. There is a NET exam. This is a NET exam question. So can you tell me the answer for this question? Tell me the answer here. A positive level logic digital circuit is shown below. This is given. So this is positive level logic digital circuit. And the question is asking what is negative level logic circuit. I told you in the class, this we have already seen in the class. What I told you, that these are actually dual of each other. The positive logic system, the positive level logics, this positive level logic, this is dual of, this is positive level logic, or I can say positive logic. This is dual of, this is dual of negative level logic, or I can say negative logic system. Yes or no? Positive logic system is a dual of negative logic system. We have already seen. So basically this question is asking what is the dual of this. Remember, the question is saying that in the positive system this circuit is given to you, in the positive level logic this circuit is given to you. The same thing in the negative logics, what it will become? The same thing, the same behavior in the negative logic circuit. Who will give the same behavior in the negative logic circuit? So basically you have to find the dual. So what is this function f? Just find this function f. Find this function f. ABC, these are the variables ABC. Then find this function f. What is that? What is that function? Or you can do like this. Or you can do like this. See, you can find the function f. The function f will be, ab bar, and there is c bar, and there is XNOR. First you are doing XOR. Okay, there is XNOR. Basically there is XNOR. There is XNOR. Okay, so this is the f is given to you, ab bar XNOR c bar. Tell me what is f dual? F dual. What will be the f dual? So you know the XNOR, the dual of XNOR is XOR. The dual of XNOR we already know, that is XOR. So XNOR dual is XOR. C bar will be C bar, and this AB bar, this AB bar means A bar plus B bar. So that will become A bar B bar. Okay. So the answer will be this. Your F dual will be A bar B bar XOR C bar. Okay. A bar B bar XOR C bar. So your answer will be what? Option C is correct. Option C is correct. Is this clear? Because see, the question is simple. F is given to, first you find f, first you find f, then when you find f, then you will get AB bar XNOR C bar. Now how to find dual? You know the dual of XNOR is XOR, the dual of C bar is C bar, and what is the dual of this? What is the dual of this? Dual of this, because remember what is this? This is A bar plus B bar. And what is the dual of this? The dual of this is A bar B bar. So it will be A bar B bar. So your dual will be A bar B bar XOR C bar. Okay, so that is option C. So answer is option C. Is this clear? CS, CS, is this clear? Now is this clear? First you find the function. See, first you find the function. Now remember, positive logic system is a dual of negative logic system. The positive logic system, that is dual of negative logic system. Okay, positive logic system is a dual of negative logic system. So you basically you have to find the dual. The question is asking you to find the dual because the positive logic system is given to you. F in positive logic system is given, this function f in positive logic system, this function f is given to you, and the question is asking the same function in the negative logic system, what it will be, the same function, the same behavior in the negative logic system, what it will be. So that will be basically dual because they are dual of each other. So the question is asking dual. So answer will be option C. Is this clear? Let me know. Option, and what about this? Option A. Option A, that is A, B. Option A, that will be A, B bar. A plus B bar. Okay, so that will be A bar, B bar. Yeah, option A is also correct. And I think, okay, so now you just check this option B. Check option B also. So option A is also correct. And what about option B? Check option B. So option B will be A bar B bar. You have A bar B bar and then whole bar and then whole bar. Okay, you are doing whole bar XOR C bar. So that will be A plus B XOR C bar. A plus B XOR C bar. Are they same? A plus B XOR C bar. Is that same as this? So your F dual that we got, F dual that we got is A bar B bar XOR C bar. Is this same as this? A plus B XOR C bar are the same? A plus B XOR C bar. Are they same? These two. So let's check whether these are same or not. Okay, let's call this E. Let's call this Z. So there are two cases possible. Either A is 0 or A is 1. When A is 0, then what will be E? When A is 0. When A is 0, then E will be, this will be E. Okay, and when A is 0, then what will be G? When A is 0, then that will be C bar. A XOR C bar, that is A B XOR C. So they are not same, right? They are not same. Option B is not correct, right? Yes or no? Option B is not correct. Oh, sorry. So this will be C. This will be C. This will be C. So it will be ops. So that will be C. So that will be C. Yes. So both are, yes. So in this situation, both are same. And when A is 1, when a is 1, then what will be this e? When a is 1, then that will be 0 XOR c bar. 0 XOR c bar is c bar, and here when a is 1, then 1 XOR c, that is c bar. So yes, both are same. So all these options are correct. So answer will be option D. So this option D is correct answer. Option D is the correct answer. Okay, so this is a nice question. This is NET exam question. NET NET exam question. Remember, the question is very simple. First option, see this, let me tell you, in positive level logic, this circuit is given to you in the positive level logic system. So this circuit means this function is given to you in the positive level logic system. Okay, in the positive logic system, this function is given to you, and the question is asking in the negative level logic, means in the negative logic system, what will be that? So remember, they are dual of each other. Positive logic and negative logic, they are dual of each other. Now positive logic, f is given to you in the positive logic. So in the negative logic, this will become f dual, because they are dual of each other. Okay, they are dual of each other. In the class, we have already seen what is positive logic system, what is negative logic system. Okay, how they are connected to each other. In the class, we have seen. Yes or no? Tell me. Go classes students, please tell me. We have already seen this. Yes or no? What is positive logic? What is negative logic? How they are connected to each other? Why they are dual of each other? The proof I told you. Positive logic, negative logic, they are dual of each other. Why they are dual of each other? I told you the proof in the class. Okay, all these things we have already seen in the class. Okay, now we are just applying them. So this function f is given to you. You just have to find what is the f dual. So the answer will be option. Okay, all these are correct. Option A, B, C, D, all of them are correct. So all the go classes students, you already know that we have already seen all these things in the class. Let's see this question. What is the answer? A circuit, a circuit which is working as NAND gate with positive logic is working as this gate in negative logic. So the, okay, in positive logic, what is NAND? That will be NOR in the negative logic. Yes or no? That will be NOR in the negative logic, because positive logic is dual of negative logic. Positive logic, negative logic, they are dual of each other. So what is NAND in positive logic is NOR in negative logic. What is AND in positive logic? That is OR in negative logic. What is XOR in positive logic? That is XNOR in negative logic. What is F in positive logic? That is F dual in negative logic. So the answer will be option B. Hopefully all these things are clear. Okay, so actually a lot of time we have taken, but anyway, so in the next session, today we will have next session. Okay, at 3 p.m. So let's shift it to 4 p.m. At 4 p.m. we will have next session. At 4 p.m. next session will be at 4 p.m. and there we will solve the questions of Cambridge University. So University of Cambridge past exam papers of digital logic we will solve. So basically, if you go to this website, you will find many questions of the Cambridge University. You will find of the digital logic. You don't have to check it out. You don't have to check it out, because we will solve all the questions, okay, in our this standard session. So like, okay, like this is a question of Cambridge University, this is a question of Cambridge University. So all these questions we will solve in the next session. The next session will be at 4 p.m. Okay, but before going for the next session, I just want to tell you one last thing. One question I want to discuss. This question: how many functions are there for which f complement is same as f dual? How many functions are there? F a comma b. What is the number of functions? What is the number of functions for which f complement is same as f dual? What is the number of functions for which f complement is same as f dual? See, these type of function, they don't have any standard name. Let me tell you. These functions, those functions for which f complement is same as f dual, we have to find those functions. We have to find those functions for which f complement is same as f dual. These type of functions, they don't have a standard name. There is no standard name for this type of function. There is no standard name. But remember, let's give them our own name. So what name should I give? This type of function, what name should we give? There is no standard name for this function. There is no standard name. Okay. So let's give some name. Those functions for which f complement is same as f dual, let's call them go functions. Okay, let's call them go functions. Okay, let's give them name. So our own name we are giving go functions. Let's call them go functions. So how many go functions are there? This is the question. Okay, so first understand the question. Please understand the question first. A B 0 0 0 1 1 0 1 1. So we have to find those functions for which f complement is same as f dual. Tell me, is this function go function? Is this function go function? So let's call it go function. Go function means those functions for which f complement is same as f dual. Those functions for which f complement and f dual are same. Is this go function? Is this function go function? Yes, this is a go function, right? Because f dual and f complement will be same. So this is a go function. I can say yes or no. This is a go function. So this function is, for this function you can check, for this function f complement will be same as f dual. For this function f complement is also 1, f dual is also 1. Both are 1. For this function you can check. Okay, so for this function what I'm saying, for this function f complement and dual both are same. F complement is same as f dual. Tell me, what about this function? For this function what should happen? Is this go function? This function, is it go function? For this function f complement and f dual are not same. For this function f complement f dual, they are not same. What about this function? What about this function? For this function also f complement and f dual are same. What about this function? For this function this is also go function. Okay, what about this function? This function is also go function. So is it clear which function is go function? Is this clear? Those functions for which f complement is same as f dual. Remember, this function is go function. See, look at this function. For this function, if you notice, f complement will be this and f dual will be this. F complement will be this and f dual will be this. So this is a go function because f complement is same as f dual. F complement and f dual are same. So this is a go function. We can call it go function. Okay, because f dual and f complement are same. Now look at this function. Look at this function. For this function, if you notice, what is f complement and what is f dual? See, f complement will be this, f complement will be this, and f dual will be reverse of f complement. This is the truth table, standard order. This truth table is in the standard order. Now what we are saying, that this is your f complement, so f dual will be what? That will be reverse of f complement. You can notice they are different. F complement and f dual, they are different. So this is not go function. So this is not a go function. So is this clear? What is go function? What is not a go function? Okay. So finally, how many go functions are there? Like number of go functions. How many go functions are there? This is what we want to find out. Now remember, f complement should be same as f dual. What it means? If this is a0, a1, a2, a3, then what will be f complement? F complement will be like this. Correct? If this is f, then f complement will be like this. And what will be f dual? F dual is reverse of f complement. F dual will be reverse of f complement. Reverse of f complement. Now we are saying that they must be same. We are saying they must be same if this is go function. If this is go function, then they must be same. They must be same. They must be same. So go function, a function is go function. I can say f is go function if and only if. Finally, what can I say? I can say f is go. I can say f is go function if and only if A0 is A0 is same as A3 and A1 is same as A2. Yes or no? A0 is same as A3, A1 is same as A2. Correct? Is this clear? Similarly, if you have three variables, let's assume you have three variables ABC. You have three variables 0, 1, 2, 3, 4, 5, 6, 7. This is your three variable. You have some function that is your, okay, let's call it A0, A1, A2, A3, A4, A5, A6, A7. What will be F complement and what will be F dual? If this is Go function, they must be same. F complement is this A7 to A0 complement, A6 complement and so on. F dual will be what? Sorry, this is F dual. Sorry, this is F dual. So I can say this is F dual and F complement is A0 complement, A1 complement and so on, A7 complement. Now finally, they should be same, they should be same, they should be same. In this situation, this will be Go function. If this is Go function, then they should be same. So finally, I can say F is Go function. Finally, when can I say F is Go function? If and only if I can say F is Go function if and only if F ABC is same as F A bar B bar C bar. Yes or no? Yes or no? Because A0 should be same as A7. This A0 should be same as A7. This A1 should be same as A6. This should be same as this. This A2 should be same as A5 and this A3 should be same as A4. So finally I can say that a function is Go function if F ABC is same as F A bar B bar C bar. Okay, yes or no? So now tell me how many Go functions are there? Go function means this is a palindrome function. We have already seen in today's session, we have already seen this is a palindrome function. So how many palindrome functions are there? How many palindrome functions are there that you already know? So answer will be, if your function, then there will be 2 power n rows. There will be 2 power n rows will be there if your function has n variables. So there will be 2 power n rows. Okay, and palindrome function means for half of these rows you have choice. For half of these rows you have choice. So finally I can say number of palindrome function. What that will be? Number of palindrome function, or I can say number of Go function. Okay, that will be 2 power. For half of these rows, for half of these rows you have choice. Like there is choice for half of these rows, there is choice, there is choice. But here there is no choice. Here we don't have any choice because we want palindrome function. So answer will be 2 power n minus 1. So for half of these rows, okay, how many rows are there? Half, that is 2 power n minus 1. So answer will be 2 power n minus 1. Please tell me, is this clear? Is it clear? Because you can notice that F, okay, so these type of all these things are same. So finally in the exam they can ask you all these things are same. Remember, if I say palindrome function, this palindrome function, okay, this palindrome function, what is palindrome function? Palindrome function means FABC is equal to FA bar B bar C bar. Okay, FABC equal to FA bar B bar C bar. And also this, for which F complement is same as F dual. All these functions are same. All these functions are same, I can say. I can also write it F ABC is not same as F complement A bar B bar C bar. All these things are same. All these things are same. All these functions are same. And how many such functions we have? That is 2 power n minus 1. So this is the final. Now let me tell you one more thing. See, we called it this type of function. What we call it? We are calling it Go function, right? This type of function we are calling it Go function. This is the name we have given, go function. We are calling it go function because there is no standard name. Okay, for this type of function, those functions for which complement is same as dual, those functions whose complement is same as their dual. So there is no standard name. So we are calling it go function. But if you go to internet, okay, today you can check it out. Okay, on Google you write this orthogonal, you write this orthogonal Boolean function. On Google you write this today. Okay, so on Google, if you write this on Google, just write this, then go to YouTube. Okay, so after that go to YouTube. See, okay, so there will be one video by a YouTuber. Okay, so there is a YouTuber whose video you will find orthogonal Boolean function. So basically this function whose complement is same as dual, this type of function, those functions whose complement, okay, those functions whose complement is same as dual, this type of function, there is a YouTuber who is calling it orthogonal Boolean function. That is fine. Name does not matter because there is no standard name for it. Remember, there is no standard name. We are calling it go function. Some there is a YouTuber who is calling it orthogonal function. So there is no standard name for it, for such function, of such functions. Like this is not a standard name. This is not a standard name. Okay, but anyway, there is a YouTuber who is calling it go orthogonal Boolean function. That video you watch, and that is completely wrong. The explanation is completely wrong. Okay, so there is a 10 or 15-minute video is there. That video you watch, and that explanation is completely wrong. So what I want to say that, see, don't follow non-standard, like, okay, always follow reliable resources. This is what my suggestion is. Always follow reliable resources. So today you can check it out, and that video, 10 or 15-minute video is there. That video is completely wrong, completely, like the complete explanation is wrong. Okay, you can check it out. So you can check it out, and this is what I want to say, that only follow reliable resources. Okay, so don't follow this type of poor resources. Okay, now anyway, next, also I want to tell you that there is something called neutral function. What is a neutral function? Neutral function means those functions, neutral function, those functions for which, okay, number of false minterms is same as number of true minterms. What is a neutral function? Neutral function means a function with same number of true and false minterms, same number of true comma false minterms. Means number of true minterms is same as number of false minterms. Means those functions, okay, for who are okay, number of 0 is same as number of ones. Okay, those functions for which number of 0 is equal to number of ones, I can say number of true minterms is equal to number of false minterms, those functions. Now, so this is the idea. Okay, a function for which number of true minterms is same as number of false minterms. For example, I can say this function, look at this function a b. Okay, so like 0 0 0 1 1 0 1 1. Like for example, let's see this function. Is this neutral function? Is this function neutral? Tell me, is this function neutral? Is this function a neutral function? This is not a neutral function because you can notice there are 3 true minterms and there is 1 false minterm. So okay, this is, remember, neutral function means number of true minterm and false minterm are same. Okay, means number of combination where function is 1 is same as number of combination where function is 0. Okay, number of combinations for which function is 1. What is a neutral function? What is a neutral function? Neutral function is those function where number of combinations where f is 0 is same as number of combinations where f is 1. Okay, so this, like here you can notice number of combination where f is 1. So like this is not a neutral function. I can say this is not a neutral function. Which is a neutral function? So you can just check it out. Which is a neutral function? Which is a neutral function? So you can check it out. This is not a neutral function. 0 0 1 1, yes, this is a neutral function. 0 1 1 0, this is a neutral function. Okay, 1 1 1 1, this is not a neutral function. So this is the idea. Okay, what is a neutral function? Now tell me, this go function that we have defined, is it necessarily a neutral function? Can I say this statement is go function a neutral function? Every go function is neutral function. Can I say every this go function that we have defined, every go function is a neutral function? Is it correct? Is it correct? What is a go function? What is a go function? Those function for which f complement is same as f dual. Okay, so every go function is neutral function. Is this statement correct? So this statement is clearly false. Go function means those functions for which f complement and f dual are same. Every go function is neutral function. This statement is false. This statement is wrong. Consider this. Array, let's consider this 0 0 0 1 1 0 1 1. Let's consider this. Consider this function f 0 0 0 0. This is not a neutral function, but this is a go function, right? For this function, f complement is same as f dual, and both are 1. F complement and f dual, they are same. So this is a go function. Yes or no? And you can notice this is not neutral. This is not a neutral function. This is not a neutral function. So basically, go function is palindrome function. Remember, go function is simply palindrome function. So how many go functions are there on two variables? If we have two variables, how many go functions? Number of go functions, all the go functions, all the go functions on two variables. Let's see. Remember, what is a go function? Go function means those functions for which f complement and f dual are same. Those functions. Okay, so how many functions are there? We have already seen. For n variable, we have already seen. What is the answer? Go function is a palindrome function. So if I give you n variable, then answer will be what? For the n variable, answer will be 2 power n minus 1. This will be the answer. So for two variables, what will be the number of go functions? That will be 2 power 1. Okay, so that will be 4. Total 4 go functions are there. 0 0 0 1 1 0 1 1. For example, every palindrome function, every palindrome that you can create, like this is a palindrome, every palindrome that you can create, this is a palindrome, every palindrome that you can create, like this is a palindrome. Okay, every palindrome you can create, like this is a okay, so this is a palindrome. So only 4 go functions are there, because go functions are same as palindrome functions. You can check. Okay, so finally this statement is wrong. Every go function is neutral function. This is wrong. Number of go functions, go function means those functions where f complement is same as f dual. So number of go functions, that is 2 power n minus 1. Okay, so you can just check it out. Okay, so this is enough for today. If anyone has any doubt, you can ask. So the next session we will start after 3 hours. No, after 2.5 hours. We will start at 4 p.m. We will see the next session. In the next session, we will solve the questions from University of Cambridge. Also, we will solve the questions of K-map. Okay, minimization using K-map. So those K-map questions we will solve in the next session. So please let me know, did you like this session? In this session, we started from some easy questions, some basic, very easy questions we have seen. Then we have seen what is number of functions, how to count number of special functions. Okay, with some property, those functions which have some property, how to count. Okay, so those we have done. Then we have seen how to find the dual. From the truth table, how to find the dual. And okay, basically now you know how to find the dual. Very easily you can find the dual. Whatever function I give you, whether I give you truth table or whether I give you, I can say SOP, canonical SOP expression, then you can very easily find the dual. Okay, so finding the dual you can very easily do. And also in the next session we will solve this Cambridge University questions. We will solve. Let me tell you one more thing. Please understand that you don't have to visit this website and you don't have to solve these questions. because throughout this year, okay, like okay, every week we will have these standard sessions. So in all the standard sessions, by the end of this year, we will solve all the gate relevant questions which you can find on the internet. Like okay, I will take, don't worry about it, I will take all the gate relevant standard questions, I will take, and we will solve them in our standard sessions. So follow the standard sessions, follow the Go Classes YouTube channel, okay, and also yes, okay, press the like button, okay, if you like this video, you can press the like button, you can put a comment, okay, like how did you find this session? Please put a comment, okay, if you are liking this session or not, we should continue these sessions or not. So basically put a comment, okay, what is your opinion about these sessions? So put a nice comment, put a detailed comment you can put, okay, we will take more questions in the next session. And also what I want to say, yeah, I think that is enough, okay, if anyone has any doubt you can ask. Okay. so so you can put a comment, okay, all the things that you are saying, okay, that those things you can put as a comment, okay. So basically help us grow our YouTube channel, okay, help us reach more students. If you think we are providing quality content, see, we are taking quality questions from standard resources, all the quality questions we are collecting, and we are giving them to you with solution, with explanation, okay, and all the misconceptions that you have, we are trying to clear them, okay. So you won't have any misconception, okay, if you follow our lectures. So so all so you can put the comments always. Whenever you like a video, you put comments. Whenever you like a video, you like the button, you like that video, okay. So these things, these small things if you do, then we will reach more students. More students will get to learn quality things, okay. So more I can say, so that's it. So I think that's enough. So thank you everyone, thank you so much. And if you want, if you have many misconceptions in the digital logic, if you don't understand some concepts in the digital logic, then you can enroll in our complete course. So in the description you can find all the link. You can enroll for our gate 2023 complete course, you can enroll, okay. So you can join there, and you can also join our YouTube channel. So basically this is our gate 2023 complete course, you can join it. In this course you will find everything. You will find live lectures, recorded lectures. If you want to join live classes, you can join live classes. If you want to watch recorded lectures, you can watch recorded lectures, okay. You will have homework, okay, you will have summary lectures, and also gate, previous year gate questions, video solutions. So basically all the things. Most important thing is, everything that you will study in a very quality manner, okay. There are weekly quizzes, every week there is a weekly quiz, okay. And this is the test series you can enroll. So you can enroll for the Go Classes plus Go Get Overflow plus Go Classes test series. This combined test series you can enroll, okay. Go Classes plus Get Overflow, this combined test series you can enroll. So you can visit this website. On this website you will find this combined test series, you can enroll here, okay. And you can join our Telegram group. So this is the username for our Telegram group, you can check it out. So just okay, and the link is in the description. See, the link of Telegram group, the link of Get Overflow group, all these links are already in the description on our Go Classes YouTube channel, okay. You can check the description, there you will find all these links. So you can join these Telegram groups, there you can ask all your doubts, and you can join also our Go Classes Discrete Mathematics and C Programming. These two courses are free for all, like complete courses, complete discrete mathematics, complete C programming, okay. All the things, lectures, weekly quizzes, homework, all the things, everything. So complete discrete mathematics and C programming, these courses are free in Go Classes. So basically link you can find in the description. Again, you can visit Go Classes website, there you can find discrete mathematics and C programming courses. You can watch these two courses completely freely available, okay. Complete courses are freely available for all of you, okay. So you can find the test series link also you can find in the description, and the course link also you can find in the description. So you can check it out, okay. So thank you everyone. So see you after the I can say, I think 2.5 hours, okay. See you after 2.5 hours. we will see another session. So session number 2 at 4 p.m. Session number 2. In the next session, we will solve minimization questions, K-map, Karnoff map questions, and Cambridge University questions we will solve. Okay. Okay. Thank you, everyone. Thank you so much.